Hi, everybody. Mr. Hayes. I'm back. And we're back to school. Welcome to fourth quarter. Welcome to after spring break. So as I get used to the format of the new videos, we'll kind of see how that goes. This one might be a little bit longer because I'm going to go ahead and fill it out as we talk about it. So if you need some help, if you want a faster one, I'm sorry about that. But I'll find a good groove here in a second. As always, like, subscribe, comment, all that other good stuff. So what we're going to be talking about today is the difference of means, which is different than the mean of differences. And so what we're going to talk about here is Stanford went through and figured out that there was if you label calories on a menu, people will tend to eat fewer calories than normal. Back in the old days, McDonald's never said 10 chicken McNuggets were 450 calories or whatever those are. Or the bacon bagel that I had this morning, I think was 700. And so anyway, so what ended up happening here to research this, investigators went to Starbucks. They found some that didn't have the calories listed. They found some that did. So they found 30 stores that had menus labeled with an average number of calories of 225. And then they compared that with a random sample of 400 receipts for stores that didn't have the calories labeled. And they had an average calorie intake of 265. And the standard deviations are down over here as too. And we'll mark those up here in a second. So then the question is, does this provide convincing evidence of what we need? So again, to highlight what we're going to do, and while you can't use highlighters on the AP test, you can use pens, blue or black pens and pencils. So I usually have my kids highlight and make notes in pen and then write everything in pencil. So things that we need to worry about here: 30 receipts that had average of 250 calories with a standard deviation of 100, and then 40 receipts, so that's without the menus, 265 calories, standard deviation of 75. Okay, so as we go through and talk about this, so my parameter here is going to go through and be mu1 minus mu2, and that is going to be the true difference of our mean calorie intake. Our statistic here is obviously going to be x bar 1 minus x bar 2. And in that case here, we have 225 minus my 265. So that's going to be 40 calories, negative 40 calories. Let's make sure that's clear. Whoa, that's a big eraser. You'll forgive me, it's first day back on a SMARTBoard in a number of months. And I know you don't care, and that's okay. My hypotheses here then obviously is going to be, my null hypothesis is, remember, just like humanity, if you don't have to do anything, we're not going to worry about it. So that mu1 minus mu2 is going to equal 0. From what we're seeing, and we want to see if it reduces it, so we're going to say, all right, it is less than 0, which so far our evidence seems to be saying that, which is kind of neat. And then for my significance level, alpha, we're going to say 5%, because if they don't tell us, that is what we're going to do. All right. So the name of this procedure is going to be a 2-sample t-test. For mu1 minus mu2. So for checking the conditions, same as before. We need random, we need 10%, and we need to make sure that we have a normal distribution. So for here, if we go back up into the dialog, we said random sample of 50 receipts, or 30 receipts, and a random sample of 40 receipts. So that is good enough for us. Random sample of 30, 40 receipts. So that one's met and worth a check. Next is our 10% rule. If you've ever been to a Starbucks, you know that 30 receipts is not anywhere near the same number of receipts that we normally have. So 1/10 of all receipts. And likewise, 40 is just a drop in the bucket. So that one is met. Ka-ching. And then last but not least, we want to check our normalcy. And so for normal, what we're going to end up doing here is, thankfully, 30 is less than or equal to 30, and 40 not less than, greater than. Spring break brain, I will blame, at least today. So 30 is bigger than or equal to 30, 40 is bigger than or equal to 30, and yes, you do have to say CLT and mark that off. For consistency's sake, I should probably do that in blue. All right. So after that, again, very similar procedures to what we're going to be doing before. Okay, so the first thing that we're going to do down here is for our mean, remember, you're always going to assume that it's the null hypothesis. So in this case here, the mean of the difference of the means of the population is going to be 0. All right. For standard deviations, it's going to be like what we did before. And remember, you have to square everything first before you guys go through it. So for our standard error, okay, it's going to be the square root of our 2 standard deviations. I like the slight delay. Sorry, I'm doing this via Zoom. Anyway, so we've got 100 for the first one, and we are going to divide that through by the 30. Plus, what was it, 125 for the second one? Check my notes. Oh, 75 for the second one. Okay, and when you go through and you do all of that math, that is going to be equal to right around 21.77. I'm going to trust that you know how to plug that in. Now, for our picture, where did our picture go? There it is. So we've got this. Okay, we have our mean here, which we're going to assume is going to be 0. And we've got negative 40 down here. Okay, so then for our general formula, remember we've got our test statistic. Okay, and that's going to go through and it's going to equal, I've written this wrong like 17 times for whatever reason. Stat minus the null over our standard deviation. All right, got it right. So then for our t-value, okay, that's going to equal, and same thing here, x bar 1 minus x bar 2 minus 0, because that's our null, right? And then we're going to divide it over our standard error of mu1 over mu2, or actually right here. Remember, this standard error here is going to be the same as what our standard error for the population is. And then from there, our test statistic falls apart rather nicely, or falls together rather nicely. So then for here, our t is going to be, we've got a number of, what's it, negative 40 minus 0 divided by that number from up there, which is going to be the 21.77. And that is going to give me a negative 1.84. Now remember, degrees of freedom here is going to be 30. Actually, it would be 29, wouldn't it? My apologies. Let's fix this up there too. Whoa, got to get those fixed. You know, this is stuff I should just edit out later, right? All right, so degrees of freedom of 29. So our test statistic then is going to be a t-value of a negative 1.84, degrees of freedom being 29. And then when we go in and plug this into our p-value turns out to be 0.038. Okay, so then from there, now here's going to be the assumption. Okay, or not the assumption, the conclusion. Extend this out just a touch. So again, assuming what? There is no difference between the number of calories between the stores. There is a 0.038 probability of getting a difference of negative 40 calories purely by chance. Probability of negative 40 calories. So there's our interpretation. Okay, so again, you remember you need to interpret it so that everybody kind of understands what the big deal is. Okay, and so then from there, because that number is less than alpha, which is 5%. Sorry, I like putting that there. Okay, then we end up doing here, we reject the null hypothesis and conclude, and have convincing evidence receipts from stores with labeled calories have a lower average calorie number than stores that don't. Have calories labeled. Okay. And yes, I could probably have made that a little bit more succinct. So I apologize up front for that. So we're going to go ahead and formalize this next. That'll be on the next video as usual, and we'll see you in a little bit.